Welcome to the next session of embedded software testing unit 4. So this will be the last lecture session of this unit 4 on the software integration, and we have a regression testing. We'll study about software integration, the considerations and other aspects, the environments, and followed by that we will discuss and study about the regression testing. Okay, to recap on software integration, we know that the integration can be done at the system level, software level, and the hardware level. So it's called a system integration test, software integration test, hardware software integration test. So to recap the integration test strategy, it is not just enough to have a component level testing, but to have a adherence at the system level, how the components interact at a module level when they are logically grouped. We need to work out a strategy to integrate those components. So there are different analogies, like in terms of strategies, as and when they are developed we can do, or you can start with the top level modules till the lowest possible units. So either way we use stubs and drivers, test drivers it is called, basically to make sure that the different stages of their development integration can be taken up. So different strategies, we had a comparison in terms of time and the neatness of the component drivers or the stubs, parallelism, ability to test the particular paths, ability to plan and control the sequences. Also, we had gone through the advantages and disadvantages of top down and the bottom up. So top down has advantages in terms of if major defects are more likely at the top level models, then this is better. Whereas in bottom up, at the lowest level possible, if device drivers or hardware dependent things are having issues, better to do the bottom up testing. So basically a look and feel of the system in terms of demonstrating what could be the architecture or what could be underneath the embedded systems can be well demonstrated in top down testing, because we have started testing from the topmost models. Whereas in the bottom up testing, we start with the lowest possible models as and when they are completed with the help of drivers, because driver needs to call them. So that is where we use the bottom up test strategy. But we need to have, that's why this is a disadvantage there, because we don't know what tools we need to use for creating the driver, or we need to have our own drivers. So that's why the disadvantage of bottom up is there. Whereas in top down testing, we need to develop the stubs. So there are a lot of small stubs that may be required. So that's a disadvantage. It may not be accurate. There could be some errors while developing the stubs itself. So it takes significant amount of effort and time in terms of developing the stubs. So that's a disadvantage of top down testing. The other type of test called hybrid test, which uses both top down as well as bottom up. So this has been preferred in many of the industry aspects where larger systems are there and where a lot of subsystems are there, having small to moderate or moderate to complex, high complex embedded systems or embedded subsystems. So it is beneficial to have a hybrid test strategy which has a combination of both tests, test stubs and the test drivers. So that means it's like a middle out approach, having both top down as well as bottom up sort of a mechanism. So this approach basically factored based on the criticality and the cost that the system has. So it is very subjective. So based on that, we can take a call in terms of using hybrid test strategy, where to apply and where to use what sort of a testing mechanism in terms of integration. So another type of integration testing we had gone through is called centralized integration. This is more appropriate where we use kernel or OS, because we cannot replace those part of the embedded system. So surrounding that, we are going to develop anything that is required. So we cannot substitute, or very difficult to substitute the stub. So this kind of a approach is called centralized integration. So surrounding the centralized part of the system is developed first and made ready for production. There are other type of integration we have gone through quickly. Layer integration, where different layers are used, like such as application, mid layer, lower layer, and the device drivers or the hardware related layers. This is particularly useful, which I think I forgot to tell, is that when we test a protocol such as network protocol, so better to have layered set of testing. So we know that OSI ISO model has transport, network, data layer, physical layer. These are the important elements. Of course, we have application, presentation, and session layers topmost of that. So this is presentation layer, application layer as a topmost. Then we have transport, network, data, and physical. So likewise, we can segregate it. So something like a layered. So we have a 7-layer approach where protocols or networking applications use this. Right. Also a model used for network systems, where protocol, network protocol, TCP/IP, FTP, IP, UP, IP, UDP, all this sort of a protocol mechanisms, we have a layered approach. So in this case, better to use a layered type of integration, where we develop the integration test in terms of layer. The other type of integration testing is client server integration. We had studied about this, where the server is stubbed when client is tested, client is stubbed when server is being tested. So it's like a collaborative mechanism in terms of client and server. This is typically used where we have a database and huge application database oriented, object based or object oriented systems we have. And my last type is a collaboration integration, where we identify different collaboration models. Those models can be integrated together. That is where collaboration integration can be done. So those are the different types of integration that we have studied. Then we came to integration test environment, how it looks like. So basically, it should have a mix of both unit level testing environment as well as system testing environment, because we need to develop a driver with the help of integrated development environment. That environment could be used for developing the system as well as testing the system level identification. Similarly, we use lowest possible device drivers, test drivers, and all that. So those features also are needed. So both sort of an environment is required for doing the integration testing. So it's like a integration model which will be comprising of both unit level as well as system level environment. Basically, we can use some of the test drivers as well. which have been working and which are useful for integration to logically test the different modules together. Additionally, we may need tools like monitors to log and read the data traffic. As I said in the protocol, there will be a logger, timestamp, and all that. To do that, we need to have a appropriate additional tools such as monitors. So, in continuation of integration test environment, so we know that software unit tests and the software integration test bed is created basically, which is comparable to the test environment for the simulation mode. So, we know that simulation, emulation, and actual hardware or target based testing are used. So, accordingly, we are going to have a test environment. So, that is where we develop the integration test environment. So, basically, prototype stage and production stage are different type of integration we can have. So, both the cases we need a test object having the executable version of the software unit, or integrated software units need to be used. So, that is basically developed based on basis of the design or generated from the simulation model. So, based on that, those integration environment will be developed. So, in continuation of this host based environment, target based environment, then host target, a mix of that can be used as well in terms of developing the integration test environment. Also, we had gone through a table from the book in terms of levels of simulation, how it can be done and where it can be used, what is the processor used. Host processor is enough for doing the experimental or host based integration testing, whereas when we use the emulator, we need to have a target, actually real target, having the target processor used. So, actual hardware in terms of memory or any transceivers or any communication devices, we need to have a mechanism such as hardware in loop or hardware software in loop, sort of a test environment for integration tests. Specifically, it is useful for hardware software integration, not the software integration. Software integration, we can have the or the host based test environment. For the target based environment, we need to have a hardware software target environment for doing the integration test. So, that is about the earlier session. Today we will study more on further integration test environment. The below table is a depiction of simulation level for hardware software integration test. We can have sort of a simulation in hardware software integration, where this table you can see the embedded software where it is going to reside. It can be on the experimental host. Some of the pieces of the embedded software can be experimented or run on the host. So, that is where the first test bed is going to be lying. The next one could be on the real hardware, which uses some of the software units, software integrated unit. In the first one also the software units will be used. There is no hardware involved. The last one being hardware software integration, the complete environment and system environment having the embedded software. So, the various processes that are being used for these three layers of simulation in the hardware software integration are, so in the first one we need a host based processor such as x86 or 386, 486 or Core 2 i3, Intel based or AMD based, etc. The OS can be Windows, Linux, whatever it could be, but the host the execution will be based on the processor, host based processor. And in this case, the rest of the embedded systems will be simulated. A plant you don't need to concentrate much, because plant is something like where we are going to have it. What is the unit called actually? The second one will have an emulator, because we are using the real target, and we need to simulate the embedded system itself completely with the help of this emulator. And the last one we have the real target, and the processor is real target. There is no emulation of the target processor. That is how we are going to have the layers of simulation level in terms of integration testing. So this table provides an overview of the level of simulation in the hardware software integration test. The columns refer to the simulation areas in the generic scheme of an embedded system. So continuation of integration test, there is a system integration test which is at very higher level of the integration test on top of hardware software or software integration test. So what we do here, the test environment for developing the system integration test is the test environment of the system integration test is very similar to that of the hardware software integration test. After all, the complete embedded system is also a piece of hardware containing the software. So it is not something different, but it is as a whole the hardware, software and the integrated modules combined together, something like a system test. It is also can be called a system test, but the emphasis or focus is on the integration of the various logical modules of the embedded system or the embedded software. One difference may be found in the fact that the prototype printed circuit board of the complete system is provided with its final input output and power supply connectors. The offering of stimuli and monitoring of output signals, possibly combined with a dynamic simulation, will take place via these connectors. So actually in the it's like something like a actual target board we are going to use, and prototype of printed circuit board of the complete system will be provided as a pre-production uh, testing, where we use actual input output and power supply connectors, and we use the system integration test strategy for doing this developed board. Basically the pre-production board, it is called as system integration test board. What it will have basically is that I'll try to draw one as a production, other one is a pre-production. We can call this as a pre-production board. So what is the difference between these two? So what will happen is if there are going to be any bugs or any fixes are needed, all those final stages of the work will be done on this pre-production board, and to test that definitely we need a interfaces, right? Like we need a debuggers, we need any of the test hooks in terms of ports. All this intermediate stuff will be part of this pre-production board, which is slightly larger than, or actually larger than the actual production board. Both will have the same processor. Basically processor is same in both the cases. What will happen is the additional circuitry that is required will be taken out. So in this case what will happen is pre-production minus additional circuit will be removed in the production board, so that it can be used purely for the deployment onto the target system or the field actually, which will be delivered to the customer, so that it will not revert back to the factory. So this is the final production board. So all these system test, acceptance test, all that will be done on the production board, whereas in the integration stage we are going to use the pre-production board. So that is where the difference is lying. Okay. So the next one is another table you can see for system integration test. This table basically depicts simulation level for system integration test. You can see the last one being added here as a real target with the system integration, and rest of the systems are prototyped, and actual plant is simulated. So this table provides an overview of the level of simulation in the system integration test. The columns refer to the simulation areas in the generic scheme of the embedded systems. So in the earlier one, we didn't have the system integration facility in terms of the actual target, and there is no experimental system. Actual systems will be there, so that is what is going to be prototyped. So this will be used for system integration test, something like a pre-production testing. This is called as. Okay, so let's move on to the next topic of the integration test. So this is basically the use case derived or use case based integration test. So what we do here is you may be knowing about use cases. Basically, this term is a derived term from the UML. I think I will have an explanation about that UML perspective, because we are not going to discuss much on the UML. Why? Because UML has its own deep study required, but basically let's understand that unified modeling language which uses use cases, class diagrams, sequence diagrams, etc. So basically it is going to depict how the system looks like. So something like a model we are going to have. So from the user's perspective, the cases that are going to be developed or the classes that are going to be developed are called use cases. So definitely we know that use cases have been developed. We have an input, what is the expected output, all that are described in use cases. So with the help of use cases we can develop the test cases, and that use cases concentrate only on the higher level modules or the logical group or the functionality or the features of the embedded software system. So that is how we can derive the test cases from this use cases. That is where it is called as integration from use cases perspective. Basically testing from use case which are further going to be broken down into test cases. So basic difference is that use cases tell the story of how someone interacts with a software system or the observed behaviors. That's what use case the user perspective does to achieve a goal. Goal could be accepting some value and computing something and resulting some other value, or achieving some of the results. So that could be a functional block for that goal. A good use case will describe the interactions that lead to either achieving or abandoning the goal. So basically the use case describes the interactions for achieving the goal or resulting the path whatever that goal is going to take for that functionality. The use case will describe multiple paths that the user can follow within the use case. So use cases can have different paths. We know that as the flow of the program control level or data level flows, and it is subjective to the complexity and the flow what that embedded system drives. Similarly, the multiple path that the use case can perceive, so will also can be used to draw the test cases. So a test case represent one set of inputs that exercise a single use case scenario. That means use cases will have multiple scenarios. So one test case for each scenario we are going to have it. So that is where the test cases have been derived from the use cases. Let us try to see more examples on this integration from use cases perspective. Integration from use case perspective, system test cases, how I am going to write it. Many systems, many system tests are designed to simulate how a user interacts with the system. To make sure that the system responds appropriately, because system needs to be subjected to some sort of interaction and the uh, response. If you have defined your requirement by using goal driven use cases, that means we are going to achieve some goal with so many paths. You can use the use cases as a framework for defining these test cases. Definitely these use cases are important and useful. Why? Because this framework, on top of which we can draw a lot of test cases, and there is a goal for this framework. The framework is basically the use cases, also called as goal driven use cases. Uh, so how are we, what are we going to come up with the help of these goal driven use cases? It's nothing but the system test cases. The system tests should be created to test a single situation. That means each test will try to test the individual scenario or the situation. When using the approach of use cases and use case scenarios to describe requirements, a system test should test a single use case scenario. So what it is trying to say is each use case or every single use case scenario should have a test case. In that way we are going to have system test cases covered addressing to the requirements. So that is where the requirements are going to be tested from the use case perspective. So the next one is how we are going to generate test cases from use cases. Use cases are based on the unified modeling language. As I said, UML is used and can be visually represented in use case diagrams. I will not detail out the use case diagrams. Maybe an example I will try to see when we are going to have a practical class of a sample UML. So use case diagrams basically will have users interacting with the system. Suppose I will try to draw a small this thing. So this is a function block, and we have a user. User will be represented in a different way. I don't have that annotated tool, but anyway. Uh, so basically this is a use case. So what it does is it tries to interact with the system, and it expects some output from the system. So all these scenarios, like we have 1 or 2 and some results like 2 and 3 and 4, whatever it could be, for that functional block, all this with the help of use case diagrams we can draw test cases. Test cases can cover from this, 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 likewise. So that is how we are going to generate the test cases for each of this path where use cases are being used with a user interfaces with the system, and the expected output, how the user perceives from that scenario. Okay, and the use cases will have the below items, you can see name and description of that use case, flow of events that use case can take, or different flow of that events, how it's going to drive, and any special requirements it's going to cover, because having the user perspective, we may cover more functionality or more requirements or any specific requirements or special requirements that are also addressed. Then any preconditions that needs to be taken care for typically executing that use case, and any post conditions in terms of after the test cases have been executed, we need to take care. So all these aspects of use case to test case will have to be taken care. Okay. So that is where we use the test cases generated from use cases. So basically, whatever I try to draw that users, it is also called as actors. Actors are nothing but the users. The users can be any subsystems or any humans or actual users. So the lines, whatever I try to draw, is a communication between the actor and the use case in terms of the flow, basically. So use case diagrams will provide a bigger picture in terms of how the functional block is getting used or perceived, and the same thing will be tested against that actually. Okay. The next one is an example of generating a test case. You can see different paths in this use case flow basically. So this diagram depicts a basic flow of events and alternate flows of events for a use case. So what is going to happen is the basic flow will be same. The user is going to use that functional block. There is an output, but to achieve that, there could be a different flows, alternate flow 1, 2, 3, 4, different colors you can see have been followed, and these alternate flows can be derived into subalternate flows as well. So in that way, we can have the multiple flows as well. So these multiple flows will have each one addressed by different test cases. It is called flow of events, and for each flow of events, there is a test case, and we need to apply all these items, all these descriptive things, all these pointers for addressing the use cases. You can see there are different scenarios, and scenario 1 could be a basic flow, scenario 2 could be the alternate flow, and scenario 3 could be alternate flow 1, alternate flow 2, scenario 4 could be alternate flow 1, 2, 3. You can see multiple scenarios here, right? So it can take this path, basic flow, alternate 1, 2, and alternate 1, 2, then alternate 3. It goes back and again it comes, alternate 4 can be there. Likewise, we can have multiple scenarios. For each scenario, one test case, we are going to have it. So once we identify these flows, for in this example 5 flows are there, we are going to generate the test cases. So how we are going to generate the test cases is set of test inputs, execution conditions, and expected results. These are typical test case writing type. Use cases act as a product requirements for generating the test case. This is where it's very important to understand that we have understood the requirements, and we have written the grouped scenarios based on the use cases. Now it's a time for us to write the test cases, and for test case writing we will not care about requirements and all on a major aspect, but we care about the use cases. So use cases will become something like a product requirement. Those product requirements will have to be addressed for developing the test cases and executing them. So this is what is the important thing. So it involves basically 3 steps process. For each use case, generate a full set of use case scenarios. For each scenario, identify at least one test case and the conditions that will make it execute. It can be more than one test case also, subject to the feasibility of that particular use case. If it requires a derived test case or more test cases, nothing wrong in having more than one test case. It should be executable, those test cases. That is where we are going to have a theoretical as well as practical procedures for these scenarios. For each test case, identify the data values with which it has to be tested. So step 1 is to generate the scenarios. Step 2 is to identify the test cases. Step 3 is identify the data values, which is very important. So once again I will repeat, read the use case textual description and identify each combination of main and alternate flows. As you can see, different scenarios, we have to identify that and understand the scenarios and create the scenario matrix. We can draw a table and identify the matrix. It could be a partial matrix or full matrix or a partial scenario, whatever it could be. But the end goal is to make sure that all the use case scenarios have been addressed with the test cases. That is how we are going to draw the scenarios. That is the first step. Second step, once the full set of scenarios have been identified, the next step is identifying the test cases. We can do this by analyzing the scenarios and reviewing the use case textual description as well. So use cases will have a description, as I said in one of the earlier section, earlier this slide. Each use case will have a description, and this description is being used as a textual input for developing the analyzing the scenario and writing the use cases test cases from the use case. So there should be at least one test case for each scenario, but there will probably be more actually, depends subjectively. So the additional test cases are basically to cover all the possibilities in terms of boundary, equivalence, whatever you want to call it, whatever we have studied earlier for dynamic testing. In addition, we may wish to add test cases uh, in terms of analysis or anything that could make it cover for all the scenarios. So that needs to be tabled out. That is where what we do with the test cases identification process. The third step will be identifying the data values for each of these tests, because data values are very important. Once all of these test cases have been identified, they should be reviewed, basically understand and validate to ensure accuracy and to identify redundant or missing test cases. Anything is missing, we need to do it. Then so once they are all understood, reviewed, approved, the final step is to actually we have to substitute the practical values or the data values for the inputs and the expected outputs. So without a test data, test cases can't be implemented or executed, right? So they are just descriptions of conditions, scenarios and paths, but actually the test data is going to identify the practicality of the testing. So therefore it is necessary to identify actual values to be used in the final tests. So this also can be done with the help of a test case matrix for each of the scenarios. Okay. So with this, generating test cases from use cases comes to an end. So next topic in the integration or continuation of the integration testing is the continual integration testing, or it is called incremental testing, or it is also called as mainly regression testing. Regression testing. So what do you mean by regression testing? It means rerunning test cases from existing test suites to build confidence that software changes have no unintended side effects. So why we need to have software changes? Why? Because when we have done the primary testing or first time testing, there are certain issues and bugs we found out on the embedded system or the software. To overcome that, we have fixed that software and the requirements have not changed. Test cases should not change. So what has to change is the result, and to achieve that we are going to have regression testing. So regression testing means rerunning the test cases from the existing test suites. Test suite is a set of test case, test procedure, and the test execution scripts on the test bed. So basically, while doing this, we get a confidence that the software has got some changes, but doesn't have any unintended side effects. The ideal process would be to create an extensive test suite and run it after each and every change. That means the test suite should be such a way that any changes in the system will not alter the execution process. So we don't have to retouch or rework on that test suite again and again, though the system is under changes. So changes means changes within the certain limit or the scope of the program. That is where the regression testing is carried out. This is an important type of testing. It is not a type, I would say it is a process which everybody will follow in all the industries. But some people do a automation for regression. They have a dedicated team for regression. They do batch automation, script automation, execution, and all that, so that every version of the software they keep testing it independently. That is where the regression testing is very important. But whatever that you want to have it in regression testing, the primary testing has to be solid and accurate and clear, so that the regression testing will be successful based on that. So definition of retesting based on standard 79251, it says that running a test more than once. That means same test is getting repeated. A simple definition. So another definition is retesting to a previously tested program following modification to ensure that faults have not been introduced or uncovered as a result of the changes made. So he calls it as retesting and regression testing. Retesting is just testing again. Regression testing is previously it has been tested, some modifications have been done for the faults that was identified, and we are going to re-execute or retest the same thing, so that we are going to fix and those faults have been uncovered or changes have been fixed. Okay, let us see in detail regression testing, why it is important, and the different definitions and techniques that are used for regression testing. Maintenance testing you would have heard, it is same as regression testing. What are the things that we are going to have for maintenance testing? Basically, this is the one. It's also called as one of the strategy for maintenance testing. There are other aspects also in maintenance testing, but main aspect is that regression testing or retesting is done. Intended changes of system behavior must be tested, but it is also possible that the system which used to work correctly in the previous release doesn't work in the new release as a side effect of the implemented changes. This is called as regression. So we know that incrementally there is some issue that it was working before, but it is not working. So What is the reason? Why? Because we found out a issue in X place and that issue is fixed. So X place is working fine, but while doing the testing of the X, we will also test Y, which was working earlier fine, and no changes on that area on that aspect, but it is failing now. So there is a side effect. So all this will be brought out. That is called as regression. Regression testing, much of the test effort is dedicated to testing that previous functionality works correctly. So basically what we do is during regression, we make sure that the earlier working testing is being working again properly without any issues. So that is where the effort goes. Of course, we know the fixes that we have done for the identified faults or errors in the early stage will basically work and is working. But the emphasis, the regression is that it is going to be checked against what was working earlier. Again, it should work the same way. So the changes can in turn be itself mapping to a limited test focused only on the change alone, or a complete test or retest of the function or component that has been changed, a test of the coherence and interaction of the change component with adjacent component. So there are three types of changes that regression testing can take place. One is on the direct point where a limited test focused only on the change alone. Means only the change we are going to address. We'll see that in build, we verify, leave it. So it's going to be working, but that may not be enough because the changes can be impacting the surrounding modules. So the second type of changes can be a complete test of the function, the entire function. Function has some small functions or subsystems, but that is not enough. That doesn't mean that it's enough to test only that impacted part or the impacted body of the function or the component, but it is better to test the entire component. That is what it means. The second bullet. The third one is while we do the testing of that particular component, we need to check the coherence and interaction of other components and the other modules which is having the interaction with the current one which is under test. So that is where the regression testing is very much important. So with every implementation of the change, we know that the risk of regression is introduced. Regression testing is a standard element in a maintenance test project. Usually a specific set of test cases is maintained for this purpose. Generally they do a sampling and maintaining. Depending on the risks and the test budget available, a choice has to be made to either execute the full regression test set or to make a selection of the most relevant test cases. Test tools can also be used effectively to support the execution of the regression test. When the regression test is largely automated, selecting which regression test cases to skip is no longer necessary because the full regression test can be executed with limited effort basically. That's why we don't need to skip. Okay. So regression testing test strategy. So what are test strategies that we can have? It is basically depending on the number of changes. So definitely regression testing can be carried out subject to how much change is there and what is the kind of change. That is also important. It's not that number of changes, 10 numbers, 20 numbers doesn't matter, but even one change can also lead to a huge risk or regression. So that is very important. Changes as basis for risk evaluations, planning and progress tracking. So the changes that have been there on the embedded software due to earlier fixes has to be risk evaluated. Planning and progress tracking also need to be taken care for the regression testing. So it can be treated in the same way as they were newly developed. That means some of the functionality needs to be addressed for the regression testing in such a way that that functionality is being newly developed and we are going to test it afresh. So the test strategy could be determining the changes. The first part is implemented change requests and corrected defects. So what is being implemented, what is being changed, that we need to determine first. Second is determining the relative importance of the changes and regression. That means we need to identify the importance of the changes and the regression importance. Third one being selecting quality characteristics. What are the quality aspects that we need to take care in terms of the checklist or exit criteria, entry criteria, all these have to be taken care. Fourth one being determining the relative importance of the quality characteristics. It is not just enough to identify or select the quality characteristics for that particular scenario. It is also important to understand the relativeness of the quality aspects. The next one is determining the relative importance per change and regression or quality. So each changes what is the relative importance of the entire system to that particular change or the particular quality characteristics. All these above steps need to be combined together to come to a conclusion. That is called characteristics combination. The sixth one being establishing the test techniques to be used. A small correction. This will become 6 and this is okay. So then we are going to establish the test technique for that identified changes. That is what the steps that are involved for regression testing. So what are the areas that regression testing has to be done or taken care? Regression is due to fixing the fault, side effects. We need to check. We know that we have found a problem in terms of fault or error, and that is fixed, and we are going to do a regression test on the fixed part. So we need to check the side effects of the fixed part also. Okay, regression due to added new functionality. So a new version of the software has come. So that doesn't mean that we need to have entire testing developed from the scratch. So what we need to do is regression or incremental testing in terms of that particular added functionality or the new functionality. Regression due to a new platform. That means the same software, same testing will be carried out on a new platform. This is very specifically important where we do a porting activity. So especially OS related things. So operating systems are supposed to work same on different platforms. It could be Intel, it could be AMD or any other sort of a platform. Linux, you take for example. Linux OS is supposed to work on different hardware platforms. So how they are going to do is do with the regression test strategy. Regression can be due to new configuration or after the customization. Some changes, some configuration. There is no software change still, but the environment or the configuration of the program or the software under test has changed, and regression is required for the same. Regression and delivery planning. So that is also one of the area that need to be taken care for regression testing. So how we are going to deliver? So as a what, incremental or non-incremental? All this will be part of the regression testing areas. Okay. So the next part is regression testing automation. It's very important to have automation as we progress the different tests. So any embedded systems in automotive, telecom, aerospace, consumer electronics, industrial automation we take. doesn't stop at one level of testing. The product is going to be evolving again and again. Requirement is going to be updated, modified, changed. The faults are going to be fixed again and again with the different versions, different similarities of software, different softwares, different portable platforms, units, and all that. Definitely, it's a high time for identifying the automation while planning the testing. Especially, this is useful for regression testing, where manual intervention is very minimum and not afford to have actually. That is where the automation is very important. And that's test suits which are going to be developed for the automation purpose should be controlled under the configuration management. So we will try to study what is configuration management, test management in the next class, next session. Incident tracking of test cases, where different incidents are going to be happening while developing the test cases in terms of test approach, test strategy, bug fixes. All these have to be tracked. Automation pays best in regression. Basically, as I said, automation is very much needed for the regression purpose, because again and again people cannot afford to develop the test cases, scripts, modify and all that, and execution especially. So you can just use the script what he has used earlier, modify according to the need, whatever the place he needs, do the execution, batch execution, whatever it is possible. Regression driven test automation. That means regression itself can drive test automation, where, as I said, we can use the batch file execution, multiple scripts execution. I have seen some batch execution goes for days, where hundreds or thousands of test inputs are taken. There is a time for execution and all that. So we used to keep the batches for overnight, and we see the results next day, analyze, rerun, again keep for days, like that. So this kind of a automation is very important for regression testing, where human intervention is very less required. And automation is also useful for incremental development, where the development is going to be evolved again and again. Okay. The next one, regression testing test strategy. Matrix of the relative importance of changes in regression. This is basically a table analyzed based on how an ML system can go for different sort of importance for testing test strategy. Regression testing here they say as 10%, but according to me it should be 20-25%. But it's an relative example how they have given based on a particular industry. You can see what are the changes of regression that are there in the left side column, and the importance they have put it in the right hand side. So altogether 100% is what the strategy they have tried to put it. The importance, change request could be there 15%, change request another one 10%, change request 17 10%. Defects are there. Some three defects are very less important, and their importance is 5%, whereas defect 1242 is a 15% relative importance. Defect 1243 is 5% importance. These importance are subjective based on the type of defects or changes that are needed. These defects also can lead to a change request. The defects are also called as problem reports. So likewise, there are different types of categories, changes, and regression aspects. So rest of them they are keeping as 40%, including the regression itself. So this is an example. So let's see basic problems of regression test. Maintenance test suite. We need to have a test suite which has to be maintained so that regression test can go smooth. If I change a feature X, how many test cases must be revised, because they use feature X. So some features are common, like a common template or a plug and play sort of a module, and that I have used in multiple test cases, and all that need to be revised just because I have changed the feature X. So that is what is the maintenance issue for the regression test. Which test cases should be removed or replaced? Which test cases should be added? So this is also very important criteria for maintaining the test suite, because test suites are used for regression testing. Then cost of the retesting. How much is going to cost for me to do a retest? Often proportional to product size, not the change size. Basically, uh, product size is 1000. If the changes is 1 or 2, it's not going to much cost me. Whereas if the product size is from 10 or 20 and the change size is 1 or 2, definitely the ratio is more and the cost is very high. So this also matters. Big problem if testing requires manual effort. Suppose we cannot have a automation for certain tests such as assembly level testing or manual analysis, etc. Those kind of regression is very tough in terms of effort, because the idea behind original testing, the same idea has to be carried out, and the people or the resources that are used has to be reproduced, and the philosophy is going to be remaining same, because the type of testing that it involves is a totally manual and it has to be repeated. Possible problem even for automated testing, when the test suite and test execution time grows beyond the few hours. So those are the basic problems of regression test. Okay, so we will try to study more on selecting and prioritizing the regression test cases, test case maintenance, how are we going to build the build process for regression test, and we will try to see an example of how regression testing is been uh, processed in terms of build process in the next class. So we will conclude on the regression test in next class, and with that we will conclude the unit 4, which is the integration test and the regression test. Thank you.